Welcome. My name is Gus. I work for a company that's based out of New York. We have offices also in Dallas and Buenos Aires. We offer call center services in the cloud and unified communication services in the cloud. We've made a great deal out of our infrastructure, trying to provide such services. We come from the integrator space, and there's something that we've learned along the way in the last 10 years working with Asterisk and other telecom technology, is that there's basically three ways to go about things. We call it the knife, the katana, and the chainsaw. The first thing we always do is obviously, where's my chainsaw? We go for the chainsaw always. Asterisk allows you to have there's so many ways to work with Asterisk and solve issues with pretty straightforward hacks. For instance, call files. A couple months ago in a conference, we were approached and we were asked, why are you using ARI instead of just throwing files into a directory? Moving files into a directory, never try copying them. And we were surprised by the question, but it was a fair one because that person, pretty much that was all they needed, and they have a system that would generate these files and move them over, and that was pretty much all they needed. So it was good for them. We usually move into the Katana pretty fast, and we start working with AMI, AGIs, and obviously ARI as well, trying to integrate into a database layer and make sure that we can spread the load across different boxes and have a centralized underlying database layer, and that's really neat. But at some point we get to the knife, and we've had clients that needed some time ago when the do not call list law came into place. They really need to make sure that they were not calling the wrong number, and those numbers were changing pretty much every 15 days, and these are hundreds of millions of numbers, and basically you needed to query really fast, and we couldn't use the chainsaw. We started with the katana, we tried the AGIs, and it wasn't working, and at the end of the day, we ended up building this really small module into Asterisk, and everything was dandy from that onwards. Now, using the knife is great, but the only the overhead that it has is that next time an Asterisk release comes out with this great new feature that you'd love to have, and well, you need to go in there and try and make sure that your application compiles and everything's still okie dokie, and if it's not, you need to do some homework, right? And some people are willing to do that. Some people do have the in-house resources to do that. Some people don't. So till everybody knows this, I'm going to be really fast and try and move into the demo. Until 11, these were pretty much the APIs we had, and from there we could go from the chainsaw to the knife. Most people stayed in the Katana level, let's be honest. But version 12 was great. Most of the Asterisk community was very happy to see it. I know I was. And there were several modifications, but the ones that I found more interesting and really in the overhauling level were PJC, the stasis bus, the bindings, obviously, and ARI as a result. So basically this is, and at least for me, it's very important to understand it. This is how I see ARI under the hood. And so basically there are the internals, and usually with your C libraries you would access those, because after all that's what Asterisk is, right? It's an open source telephony toolkit. And they build this stasis bus on top of it, and we've got the HTTP bindings, and finally the RESTful API, which is the HTTP plus the the WebSockets channel. So I just like this slide, sorry. So one thing that I've been seeing is that there's been an API revolution, and is it just me, or is it that APIs are no longer these programmers thing, right? I mean, for programmers, API, it's an API, right? There's nothing new about it. But APIs have gone way beyond the frontiers of programmers in the last couple of years. And so I went to the web and do what everybody does. I just Googled it, and there's this website called Programmable Web who has been monitoring the public APIs, right? Such as Twitter and Facebook's API and LinkedIn APIs and so on and so forth. And I was amazed because I was expecting what I expected a rational number to be. And right now there are over 15,000. And they've been doubling every year since 2006. So this is not a minor thing. And so I'm extremely happy that Asterisk is going in that direction as well. Because there's definitely a need for APIs, or they're being consumed out there, right? So also the thing is that there are different kinds of APIs, right? Because in this big API world that there's around 50,000 publics out there, not all of them are alike, right? And so it's very important to understand that Asterisk API, it's a REST API, it has WebSockets, but the things that you are accessing to are pretty much internals. And it takes some time to understand this. Even for people like myself, who has been working some time with Asterisk, it takes some time, and when you're working with the API, sometimes you find yourself going into the old ways. It's impossible to avoid it. So obviously you need to code here, right? Because the API in itself is extremely simple, right? But it has two components, like we said. The REST part of the API, it's straightforward, right? It's a URL. So everybody can type it. Anybody can type it. It's not a good thing to type it directly, obviously. But the problem is, okay, what do you do afterwards? Because once you trigger that, right, you have control over what's going on only if you know what's going on. And this is not as trivial as it is in the dial plan, because in dial plan we have a procedural script, right? You have one line after the other, and so when you write it, you know what's going to happen, right? That's not the case with ARI. So the libraries you will find, I added one up to PHP ARI, which, by the way, I saw a presentation yesterday about it. It's amazing what it does. It does a lot. Out of these ones, because of internal reasons, we've been working with the Go one, which is pretty incomplete. It's not on the wiki for a good reason. As a matter of fact, when we started working with it, we realized we had to write parts that were missing, like devices, for instance. It was not there. Okay, so why a dialer? Well, we are integrators, and so basically we have clients that do a lot of dialing because they're VPOs, and they request dialers. We provide them. Everything's peachy until we find a client that has a very specific need and wants to do that every single time. And that's basically political campaigns, right? Because in political campaigns, there's basically two types. There's the preview dial for the campaigns that they want to be very, very careful about the contact, and then there's the other, right? Which is basically pretty much a robo-dialer. So they don't need a lot of fanciness in the interface. They really won't need to load a big amount of numbers and be able to monitor real time and be able to modify the strategy as they go. It's not like they load a big chunk of numbers, 10,000, 20,000, or 100,000 numbers, and they let it go. They need to be able to stop it and modify it and even add new numbers to the campaign dynamically. And that was a great case for ARI. So I'm going to jump into showing. That was really fast into the but I'm gonna try and show the evolution of what we did. Before we go into it, basically, the easy scenario is basically dialing out and playing back an audio, right? And that sounds easy, but and you could do it with call files, right? You could do it with pretty much anything, really. But the extra we found in ARI are the metrics, right? When you're working with ARI, you really know everything that's going on every single time. It's really real time. And so also there's an extra advantage, which is you don't need an extra piece of code to monitor what you're doing because you are the one doing it. You're in full control. So any event that happens, you need to decide. It's really up to you where you send it, right? And for us, it was very, very important how much of the playback they were listening to, right? And if they stayed longer, because after that, there was an option to talk to a representative and so on. And so that was, to us, was very important. And what we did is in the dialer, we embedded basically a login system, and we didn't want to clutter it. So what we did is we sent those events out to the outside, also via WebSockets channel, into the monitoring system, which could be built in anything. In this particular case, with data mix, that part is built in PHP, and this part is built in Go. So let me see if I can. Oh, this is cool. I don't have to move things around. Sorry. Now let's make sure we have everything. Okay. So since I don't trust convention centers' Wi-Fi connections, I am not sending this out into a trunk. I'm just using one of the soft phones as a simulated trunk. It's from the Asterisk standpoint is pretty much the same, right? So that's not the hold on. Let me see if I got it here. There's okay. Yeah. Okay. I'm not as neat as most people. I don't tend to clean things up. Sorry. Okay. Oh, another thing that was really easy to build into this tool was, and actually it's most of the work, it's the loaders and the queues, because right now there's three main components to this dialer, which are the loading process, right? This is database driven. And there's the queuing for both the numbers and the endpoints, right? Because the first version we did is, okay, let's make it dial and let's do what every dialer does. Let's send it to Asterisk into some context so it can do what it needs to do, right? And that makes sense for most dialers because most dialers end up dropping you into a very complex IVR where you choose what you need to do, yada, yada, whether they call you for a product or something like that. But in this case, that meant only dropping you into a small piece of dial plan that will send you into a real queue. And that's another thing that's really neat about ARI. One of the big differences with AMI, right? So we know which are the endpoints that we want to get the events from. So we know the state of each endpoint, right? And we know not only if they're talking or if they're on hold or whatever it is that they're doing, we also know if they are not registered at all, for instance, or they're back on the rooster because they registered for whatever reason, somebody tripped or whatever happened, right? And so quick enough, we realized that this whole work of dropping the call from ARI into the dial plan was really not necessary, and we went the extra mile and basically made a small queue to monitor the endpoints and send the calls directly into the input. So that's why I have different versions here. And which one to do? Let me show you the dial plan first. Okay. So what happened here is that the application got registered, right? One little extra we added This is not the full version. This is really like a simplified one, because otherwise it would have been too much for a small demo. But the other thing we realized is that, okay, how do we control this dialer? And okay, we're sending the events out to the wallboards via WebSockets, and Go, just like Node, is very friendly towards HTTP requests. To build a web server is pretty straightforward, and to handle those requests. So what we build is, into the dial, we build a small REST API as well, so it can be controlled by other applications, basically by a web application. And this gave us an advantage, because right now what we can do is we can put 1, 2, 3, however, I mean, we don't really care about the amount of Asterisk servers, and one Nexa dialer into each one of those, and centrally distribute the calls just by REST commands. So in this case, this is a campaign with a single number, because otherwise it would, I mean, we would need really a lot of subphones running. And so I'm starting it from the web server into the dialer, and the dialer, who's already registered both applications for incoming and outgoing into the stasis bus, is waiting basically right now. And so what's happening is that it's calling the trunk outside, right? I'm answering it, and now it's calling to the inside. I'm picking it up. Right now I'm on the call. I'm gonna close it so we see all the events together. Stop it here. Obviously the dialer keeps on running. It's not normal for us to output all of that information. I'm gonna stop it so it doesn't keep on going. And so what we have here are the output of the events that the stasis bus is sending to the application, right? And what we have here is pretty much what you would see in the dial plan. Here's the application that was registered, and here's where the call started. This is the outgoing call into the trunk. It would be, in this case, 6001. There's the playback, and here you can see that all of a sudden we've jumped into the dial plan. Now, I'm not sure, and I'm lucky to have the opportunity to later on also be here with Matt, Jordan, and Nir, and I'm going to ask them this question. So it's going to be the opposite, because jumping into the dial plan in paper, it seems pretty simple. It just didn't work the first time we tried it. And even though we're trying to send it to a very specific context, which it doesn't really make a lot of sense, I know, from the ARI perspective, but we're trying to test this scenario, and we realized it was always constantly jumping into the context that we defined the outgoing endpoint in the first place. It was not, yeah, look at me, but that's a question. So, but you know, we have other options, and what we did is we'd still use continue, but we said certain variables in the ARI application before jumping into the dial plan, and basically we evaluated those into the dial plan. So that worked. It wasn't elegant, but it works. So this is not what we liked. So we moved into a different application. And what was it here? I don't want you to go through all the. Okay. Yeah, let's do this. Oh, there's one case missing here. Okay. There's an intermediate actually without the dial plan, but this one has DTMF as well. So this one basically waits for the callee to basically choose an option, and then based on that option you route the call, right? DTMF is pretty straightforward. Playing back is pretty straightforward. I will show you now. I won't bother you with all the code, but I will show you the percentage basically between the HTTP request that the code has and the amount of code that it has basically to handle the call. You'll see that the HTTP interaction is very, very little in comparison. So the other thing that you will definitely need if you go for the Golang library is you'll have to take care of timers. It's pretty good with Go because all you do is you just import the timers library and it's got everything, timer stickers, everything. The other thing that you should take care of if you're doing it with the Golang library is Go itself. It's awesome, but it has a tendency to be extremely awesome. And so the problem with that is that if you have multiple cores, which you will do, I hope, it will in itself spread the load. And when you're working with queues, you might run into messaging issues where basically a process running in the queue, a process from the queue, a Go routine basically, running in one core will have problems with if it needs to talk to a Go routine running on a separate core. So you'll have to do something that's called channels. That has nothing to do with the Asterisk channels, but basically is a signaling system. Other than that, Go is great. It has very beautiful syntax, and it's very intuitive and clean, and it's pretty much awesome. I just got a message. Sorry for that. Okay, so this one is pretty much the same, but the difference is that it will playback, and it will wait for a DTMF for a certain amount of time, right? And hence the timer, and then it would, after that, it will send the call into, there's a playback there, select one, and there it goes into the agent. In this case, the only available agent is this one, okay? And there you go. So that's with DTMF timers and no jumping into a dial plan. Okay, in this case, you will see that there is no dial plan entry, right? That's another thing that I did a similar demo a couple of days ago, and somebody asked me, but when I go into the wiki, I tend to believe that ARI applications need to start from the dial plan. That's not, I'm pretty sure it's not the case. But you can get that impression because the first example and a couple examples start sending a call from the dial plan into the stasis application. Okay, that's not the case. In this case, every case that I've shown you has been triggered from the outside and has registered an application into the stasis bus from the outside. And in this particular case, we've never jumped into the dial plan, right? All of this was handled by the ARI application from the beginning to the end, okay? Just wanted to clarify that because I was amazed at the question the other day. Okay, let me see. And it's toy sessions. Okay. Well, the middle one, the middle one is with the loader. So there's no real difference there. Nothing very important to see in the second one. I don't know how I'm doing that. Oh, I'm almost run out of time. What I wanted to wrap up with is, let me do this. It's not fancy, but that's not, sorry about that. And you got to see all my backups. Good. Okay. So what we've learned with working with ARI is that first, it hurts because you're always going back to the way you used to do things. Then you start feeling comfortable, and the moment you start feeling comfortable, you start making really big applications. So what we've tried to do, because we don't have endless resources, is to stick to the scenarios that make sense for us with ARI. One question that I've got is, okay, since you started building a small queue, why don't you go ahead and build an entire queue, right? Just like, like app queue in Asterisk. Well, there's your answer. App queue is there in Asterisk. Why would I write it again? Unless there's a very compelling reason, like this dialer, for instance, because this dialer is able to scale out in a very easy fashion, right? And that's what I'm seeing ARI as, and that's my personal take on it, is I love ARI because it makes me treat Asterisk as a black box. It allows me to say, okay, these are all the internals and I can play with them. Okay, I'm fully responsible for them as well. Okay, there's no fallback. Like if I create a channel, the channel's there, I'm in charge of taking care of it, okay? But it allows me to have Asterisk as a black box. And all of a sudden, it doesn't need to be a Asterisk. It can be as many as I want, because it's as easy to handle one that it's easy to handle 100. And that's why we're very, very interested in keep on trying ARI and developing applications that help our clients. Hopefully we will. Any question? Sure.
Does your dialer, or how does your dialer handle answering machines? How does it detect them and how does it handle them?
Okay. Answering machine detection is not an ARI issue. It's not an Asterisk issue. It's just an issue, right? With political campaigns particularly, what we do is we put a feature code, basically, DTMF, and it needs to go into the agent. So you need to either use time detection for the DTMF, and if they don't press it, just let it go. We really don't try to detect answering machines anymore, at least in political campaigns, especially in the preview ones, especially when there's an agent, because those kind of campaigns, the contact with the agent is very, very important. It's not just a playback. And when there's a playback, it really doesn't matter that much. So the short answer is we haven't had to implement answering machine detection. I believe that if you had to, you would have to write it. Any other questions? Okay, I think I'm done. 31 minutes on the dot. Thank you.